Hi, this is Akats, the math tutor from the Education Academy Hong Kong. So today we'll go through some study tips regarding Math AASL, okay, so that you can better prepare for the exam in May and November 2022. So today we'll go through integration by substitution, okay? So the very first thing you should have is a mind map of integration techniques, right? So basically in our syllabus, right, we will be tested on like these three parts of integration. Okay, the very first part is simple integration rules. Okay, we will go through those rules later. Okay, the second one, right? The second step would be, right, what if we can't solve the integral by simple integration rules? Then we'll go to the second step, which is integration by substitution. Okay, and if we can't solve that through step 1 and step 2, the third step would be only appeared in paper 2. It must be solved by GDC. In other words, it must be a definite integral, right? A definite integral. That means it will be asking you to integrate a certain function with boundaries, okay? With boundaries given. Okay, so a very quick review on the simple integration rules. So the first one will be the power rule. So let's say, for example, x to the power 3, when they are asking you to integrate that, right, the answer would be, right, the integral would be x to the power 4 over 4 plus c, right? So the second one is the composite function with the formula of ax plus c inside bracket, right? So once again, we are just making use of power rule. Right, so it becomes 3x minus 4 all bracket to the power of 6 over 6 and then plus c, right? But remember, you have to compensate by 1/3, right, in front of the first term, okay? And then natural and exponential function, right? So the integral of 1 over x would be natural log of absolute value of x plus c, right? For e to the power of x, it would be e to the power of x plus c, right? It's just the same thing, right? Because think as if like you're doing the differentiation, right? So the derivative of e to the power of x is e to the power of x. So when you do the anti-differentiation, which is integration, it will go back to e to the power of x again. All right, for trigonal functions, right, the integral of sine x is negative cosine x, right, plus c. And then for cosine x, it will be sine of x plus c. Okay, so good. If it's good, then when do we use step 2 then, right? So okay, so now we know that it's gonna be it's gonna be the case that where we can't solve it by step 1, right? How do we detect whether integral it's going to be asked on integration by substitution, right? So of course, when step 1 fails, plus you will see the fact that now the original function, right, and the derivative occurs in the same integral, right? Occur in the same integral. What does that mean? Okay, let's look at this, okay, right away. For example, okay, so here we have we are being asked like to find the integral of 2x e to the power of x squared dx, right? So if you observe this integral, you will see that x squared, when you try to differentiate that, right, you will see 2x. You will see 2x, right? So therefore, right, this is the original. This is the so-called original function. And now this is the derivative, right? The derivative of x squared is 2x. So we see the original function and the like derivative in the same integral. That means we are going to use integration by substitution. So the first step is let u be x squared. Second step, right? So let u be the original function. So the second step is to find du dx, right? Du dx, right? Which is 2x. So therefore du equals 2x dx, right? And now we can substitute everything we replace everything with u. So basically, now it means that we're doing the integral of, so 2x dx becomes a du, right? and then e to the power of x squared, that x squared becomes a u. So at the end of the day, we're just integrating e to the power of u with respect to u. So it will be going back to simple integration rules, right? The ultimate goal of integration by substitution is to make everything back into simple integrals so that you can use the simple integration rules, right? So therefore, the integral will be e to the power of u plus c, but don't forget step number 4, right? You have to replace u back with what you assume at the very beginning in step 1, right? So it will be e to the power of x squared plus c. Okay, so good. All right, let's look at example 2. Example 2, find the integral of natural log of x over x, okay, with respect to x. So we can basically treat natural of x over x as this, right? Natural of x times 1 over x. So by observation, we know that this thing, right, when you try to differentiate that, it becomes 1 over x. That means 1 over x is the derivative of natural log of x, right? So we see the original function and its derivative in the same integral. That means this is the hint for integration by substitution. All right, so now we can, okay, go through the first step again. Let u be, okay, natural of x. And the second step is to find du dx, right, which is 1 over x, right, 1 over x. So du equals 1 over x dx, right? And now we can replace everything with u. So 1 over x dx becomes du, right? And natural of x becomes u. So at the end of the day, we're just integrating u, right? So which is u squared over 2 plus c. But don't forget step number 4, we have to replace everything back with something related to x, right? So it's just natural of x all squared over 2 plus c. So is it good? So this is example 2. All right. Example 3, right? So cheating for the integration by substitution. What does that mean? Okay. Let's say for here. Okay. So if you try to observe, right, the things inside the bracket, 4x squared minus, 4x squared plus 6, right? When you try to, differentiate that, right, you will have 8x, right? But outside there's only 2x, right? But you can actually manipulate the numbers in order to get to the derivative. Okay, so how exactly does that work? So let me show you. So let this time u equals 4x squared plus 6, right? So now I'm going to find du dx, right? So du dx would be 8x, right? So du would be 8x dx. But you can see, right, inside the integral, what we have now is only 2x dx. So how can I manipulate the numbers? I can actually multiply both sides by 1/4, right? So I got this. 1 over 4 du equals 1 over 4 times 8x dx. So that means 1 over du would be 2x dx. So now I can replace the thing in orange with 1 over 4 du. So therefore, right, this right now will become 1 over 4 du, and then in the bracket it's u, right? So u to the power of 7, right? So you're actually integrating 1 over 4 u to the power of 7 du, so you can move the 1 over 4 outside integral first, right? So you're just integrating u to the power of 7, right, du. So that means it becomes u to the power of 8 over 8 plus c, whoops, right, plus c, right? And at the end of the day, you're going to replace everything back with x. So 4x squared plus 6 to the power of 8 over 8 plus c. So good? All right. And the last example, right? So you see find the integral of sine of x squared dx, okay, from 1 to 2. But the thing is, we never learned how this is being integrated, right? We can't use simple integration rules. We don't see the original function and the derivative in the same integral. That means this must be using GDC, right? And this must be a pivot to question. All you have to do is just directly plug this in, right? With the numerical integral function, something like that in your GDC, and then they will give you the answer directly. Okay, so I hope you have a better understanding of the integration by substitution. Okay, and some students may think about, okay, so what about the AI high-level students, right, where they are being asked with trapezoidal rule, and the AHL students where they're being asked with the integration by parts, right? So if you want these videos, let me know in the comments, and then we will definitely make some more videos. Okay, and don't forget to like, share, and subscribe if you think the video is useful. See you guys next time.